Well, good afternoon. Thank you for joining us. Since it's just right after lunch, I wanted to start us off with a joke. So I'd really appreciate the laughs, if it's a terrible joke especially, because, we're nervous up here. So there are two types of people in the world. Those who can extrapolate from data. All right, thank you. All right, so we are from Databricks. And as you guys hopefully know, we are the team behind Spark, and our mission is to make big data simple. So our talk is going to connect to a lot of those concepts. We're going to be talking about structured streaming, which is, the approach is basically to simplify the streaming component of Spark workloads. And we're going to be demonstrating our product, which is basically a unified analytics platform.
So as solutions architects at Databricks, we talk to a ton of clients and we run into a wide spectrum of challenges that they need to solve. But of those things, a few things come up really frequently. And one of them is, hey, we have a ton of streaming data, it's incredibly growing, and we also want to incorporate machine learning into our streaming pipelines down the road. And so we thought, okay, well, why don't we do a talk? Let's figure out what we can do with the tools that we have in-house. We have a lot of stuff happening with structured streaming, a lot of stuff happening with machine learning. So let's put together a pipeline. So a lot of the clients that we're talking to, you can tell that there's a real growing need for this type of real-time analytics. For example, I came from one of our clients, Media Math, which is an ad tech company. And in ad tech, it's incredibly important to be able to ingest all of these real-time touch points, impressions that you're serving, purchases that are happening, and be able to run your analytics to understand how much value are you driving in real time. Can you tell your customers, how many clicks they got, how many impressions, how many purchases? And in addition to that, you want to be able to train machine learning models to best predict what's worth spending a customer's money on to get the maximum return on your investment.
Yeah, that's right. And we see a lot of changes happening to existing and well-established business models as well. So, for example, if you're a financial institution and you're processing a bunch of transactions like credit card transactions or other types of financial transactions, you may want to increase your ability to detect fraud. And that has a tangible connection to business value for these institutions. So if they can reduce the time to identify fraud, they reduce their potential risk. We also use it at Databricks. So streaming is a core component of the way that we monitor our production systems. So we're a managed cloud service, and each of our shards, each of our customer environments, we are capturing metadata and performance data and making that available to our engineers in real time so that we can identify any issues with the data or any issues with the environments before there are problems, or respond quickly to those.
But as you can imagine, and as I'm sure a lot of you have faced yourselves, there are a lot of challenges to building streaming pipelines and to incorporating machine learning on top of that. Firstly, it requires connecting a bunch of tools. And in this example, we're going to connect a Meetup API to Kinesis Firehose delivery stream, to structured streaming, to Spark ML. So lots of stuff going on. And on top of that, streaming data itself comes with this inherent complexity beyond what you see in your typical static type of data sets. And so we're excited to use structured streaming, right? Because that handles a lot of that complexity for you. It gives you a very approachable framework that has, an elegant syntax where you can actually kind of focus on what you want to do with the data, the transformations you want to make, getting it to a point where you can build a model on top of it instead of kind of worrying about all the stuff under the hood.
Yeah, and so when we're presenting this using Databricks, we're providing a means to have access to these complex concepts and build these complex pipelines in a simple and easy to approach environment.
Great. So while we were trying to figure out what we're going to do for this talk, we are trying to align on the right data set. And we decided on meetup.com because they have an open API. So one of the great things is when we give this code to you, you can take it home and play with it. Their API is totally open. And they actually have a streaming API as well. So if you RSVP to a public event and your settings are on public, I guess it might be, that'll get posted to an RSVP stream, and that stream is just kind of rolling all the time. So we plugged into that RSVP stream as our baseline data set for doing some real-time analytics and as our baseline data set for building a model. For the model, we thought, there's not really enough metadata in this RSVP, so let's layer on some stuff we're going to pull in from the Meetup API, or the members API from Meetup, and the events API as well. And the model that we kind of set out to build would train offline, because for the most part, a lot of people talk about online training or training in real time, but for the most part, most use cases actually don't require that. It's a lot of overhead for, typically you're training on way more data than you need to act on, way more data than you need to kind of be updated in real time. And so we did this offline training model where we're taking those member event and RSVP data sets, combining them into a model, and then we're actually able to serialize that model out using Spark ML pipelines, and then bring it into a real-time scoring application where we'll pull in member and event data and generate a predicted RSVP. And what that actually looks like, sort of still from a high level here, is this solution framework that we developed where anything in an orange box is code that we wrote in Spark or in Databricks, and anything in a white box is a service that we use, and we're essentially piecing all this together to generate that Meetup prediction that you see at the bottom. So we're going to go step by step and kind of take a look at each piece that we wrote of this solution, starting with the Kinesis producer. So the first thing we did was to generate a Kinesis producer, so essentially just a Python client that would fetch records from the Meetup API and then push them into Kinesis Firehose, which would then write them into an S3 bucket. And we used a Python script because they had some convenient libraries for handling those two services. One, requests, which makes it easy to handle the JSON requests from the API, and then Boto3, which is essentially an SDK to work with the Amazon Firehose, Kinesis Firehose. And so the two snippets we're looking at here, we have requests, which says, hey, grab the data from this URL, and then Boto3, push to Firehose, put record batch into my Firehose delivery stream. And so I'm going to pause there and actually bring us over to an example directly in Databricks where you'll see the code. It's not something you have to run in Databricks, obviously. It's a pretty lightweight application, right? You're just plugging into an API and then pushing it right back out to S3. But I thought it'd be great to show you guys exactly how you can run it all within the same environment. So in this case, you can actually access the driver of your cluster. So we're just setting our AWS credentials in that driver. We have the script right here that we're writing directly through the shell into the driver as a Python file. And you saw kind of the two main components of this, which is get the data from the API and push it out to Kinesis. And then after that, you can see we can just install all the libraries we need directly on the driver and then trigger the producer to run. Now, once that producer is running, what's happening, right, is it's connected to Amazon, it's connected to the stream, it's taking all that stream data, it's now pushing it to Amazon, and Amazon Firehose is pushing it down to S3 to an S3 bucket. And we'll take a look. Now that that's streaming into S3, it's really easy for us to pick up in Spark. So here's an example that we can just go ahead and start running. Cool. So the first thing we're going to do is load the schema. We've already serialized the schema for this data set since we've been working with it. That's a really quick way to get up and running. A lot of people infer schema for certain things for when they're working in batch mode. That's really slow on performance, so it's not recommended best practice. And it's a bit trickier to do in streaming, so good to have your schema serialized whenever possible ahead of time. And then we set the input path equal to the S3 bucket where we're pushing the data from Firehose. Apply the schema, and then create our streaming readers. So if you guys are familiar or seen the demos for structured streaming, you'll notice again that kind of elegant syntax where instead of spark.read, which we use for our batch jobs, we use spark.readStream. We apply that schema, we give it the path, and it's really straightforward. It goes ahead and initializes that stream for you. On the second line here, you'll see streaming counts. So we create a query that we're running, a streaming query that we're running on this data set as it continues to go, where essentially for this, we're just looking at RSVP data. And for the sake of simplicity, let's just do a count grouped by the country that that group hosting the meetup is from. And then to get the stream actually running, we have to do a write.start. So instead of your batch spark.write, we do a write stream. The other great thing about running this in this environment is that you can see visualized metrics on your streaming data. For example, your input rate, just like some health checks, batch duration, things like that. And then you can run queries immediately on the data and get some visualizations. And as we see this stream progress, as we see kind of data come in, if this graph wants to load, there we go. You'll see that as we load more and more data in here, when we run this query and get the plot below, it'll continue to change based on that streaming data. Cool. And with that, I'll pass it off to Miles.
So now that we've explored the data a little bit, let's talk about how we could use this data to build a machine learning model. So the Kinesis producer that Carol just walked you through is now persisting the data as S3. So what we can do is we can build a pipeline that retrieves that data and looks up any associated data. So in this case, the goal is to predict whether a given member will RSVP to a newly announced event. So this is like a very real problem that meetups have. This happens to me all the time. I am one of the co-organizers for the Richmond Spark meetup. And we will work with people who are hosting our event, and they'll ask us, how many people do you think are going to show up to your event? How many people are going to RSVP? And we see that a great number of people RSVP the day of the event or a few days before the event, which makes it challenging to coordinate. So the goal here is to provide a tool for meetup organizers like myself who are trying to get a better idea for how many people will attend their meetup. So the first thing that we need to do is we need to find a way to identify the most, or the aspects of the data set that contribute the most value in that prediction that we're looking for. So what we discovered was each member and each group has an associated set of tags that they can identify that might make other interested parties attend their event. So for example, we might see for the Richmond Spark meetup, Spark is a topic, technology is a topic, maybe Hadoop is a topic, et cetera. On the meetups, or on the member side, we may see that I'm interested in technology, I'm also interested in cat gifs, or the associated things that may not relate to a Spark meetup per se, but in the context of a trained machine learning model, give a better picture into whether or not I will RSVP to a given event. So we're going to perform a bunch of transformations on these data. There are a bunch of other aspects of the data that we're going to consider. So for example, I may bring guests. How likely is that going to contribute to me RSVPing for the next meetup? And we'll take all of those columns in the data, we'll do some feature engineering, and we'll transform that into a feature set that we can pass into a model. In this case, we're choosing a simple logistic regression model to keep things straightforward. And from there, we can make predictions against these data. The way that translates into Spark code is using something called a pipeline. And a pipeline is a really neat concept that lets us chain these different transformers, estimators, and models together. So in the example that you're seeing on the screen, we're creating a pipeline object, and we're setting the stages for this pipeline. So it's basically a serial pipeline where every record that passes through, or the data frame that's passing through this pipeline is operated on by each component in the pipeline. And separately, we've defined maybe what our transformers are, what our estimators are, and our models are. So each of these have parameters, input column, output column, those types of things that we've defined elsewhere. The really neat thing that we can do with a pipeline object is we can fit our training data to this pipeline. So it'll take that training data, it'll pass it through the pipeline, perform those transformations, and train the model. That model we can then serialize and save to disk for future scoring. So as Carol explained earlier, what we've observed with customers is that the access to relevant data is a big challenge when trying to do something like online learning or online model development. So if we are operating in a batch capacity, we can get access to all that data, we can train a very complicated model, and we can serialize it to disk for later use. Now let's move on to what we would do to incorporate structured streaming to evaluate that model. So when it comes to evaluating or making predictions in a model, we have to score it. And the way that we can do that using pipelines is to basically load that serialized model and get access to our streaming data that we need to score. So in this case, we're talking about newly announced events. So maybe the Richmond Apache Spark meetup is announcing a new event. We want to predict the number of members who are going to RSVP to this event. From there, we can maybe realize that each event is associated with a group, so maybe we need to look up the associated members in that group. And then we basically take that group of members and we pass them into our model and score each member and create an outcome whether or not they will RSVP or not. And that's what we would like to do, except there are limitations in the ML libraries with structured streaming. And this is a really critical component that we want to take some time to discuss. So currently, structured streaming does not support some key operations that are needed by the machine learning estimators, transforms, and models. So, for example, if you're building something like a support vector machine or you're building a k-means model, you need to perform aggregations on the data at various points in training. And we don't right now have a good mechanism to do that as of 2.2. So the way that impacts our ability to build these streaming models is that certain types of transformers and models are just not going to be supported. So we've given you a list here. I mentioned k-means and support vector machines. We also lose the ability to use the string indexer and a bunch of really critical transformers. And for the sake of this talk, we wanted to restrict the scope to structured streaming. So what some of you may be wondering is, well, how does this impact other types of machine learning approaches or other types of streaming approaches? And those are definitely some valid concerns, valid topics to bring up. We just wanted to focus on structured streaming for this talk. So in order to get around these limitations, we had to re-envision our model. And so what we did is we looked at the set of transformers and models that are supported currently by structured streaming, and we re-envisioned our model using just these supported transformers and models. So in this case, you can see we are no longer using our count vectorizer. We're now using a binarizer, and we're basically tokenizing those topics and hashing them before we pass them in as features to our logistic regression model. So what I'd like to do is I'd like to transition to Databricks and show you how we implemented that.
And while he's loading that, so while the talk is centered around structured streaming and the combination of that and ML, while we're centering on structured streaming and, sorry, I lost my train of thought. I'll pass it over back to Miles.
So let's go ahead and look at how we train this model in a batch capacity. So the first thing we need to do is retrieve our schema. So we've serialized it to disk so that we don't need to specify it each time. And so as you can see, our meetup data contains event metadata, group metadata, and member metadata. That's going to be really critical for defining our model and extracting those relevant features. So as you can see, for a given member, we have a member ID. We also have, for groups, we have the city that a group is located in, the state, various topics, et cetera. So we mentioned earlier that we're using 3 different data sources to train this model. Obviously, with data frames, it's really easy to join this data set together. So what we did is we joined the RSVP data with the member and the event data so that we could train our model. We performed some manipulations on the data to prepare it for our pipeline. And now we define the pipeline. So as you can see, this is the pipeline that is supported by structured streaming. So we have our binarizer, tokenizer, et cetera, and we've defined these and set our parameters that are relevant here. And then we build our pipeline, and we set our stages. And once that's done, we can fit our model. So we're not going to do that live. We've already done that, and we've serialized it to disk. And so here you can see, basically, we took our model, which in this case was defined and fit by a pipeline. And we saved it and stored it to disk. Oops. And then we also persist the schema for future use. So now let's talk about how we can use structured streaming to score this model. So again, what we're going to do is we're going to use our schema tools, and we're going to deserialize our schema. So this one I will be running interactively. So in this case, I have stored our schema to disk, and I can show you what's going on here. Basically, we are reading our schema file. It's just a JSON file. We're reading that as a schema object. And then we're loading our pipeline model that we've serialized to disk. So that's really simple. We basically create an instance of the pipeline model and just load that serialized model. And then from there, we're actually going to define a streaming data frame. So what I'm going to do, and the goal here, is to create a data frame that I can score. So as Carol described earlier, this is basically that convenient syntax that we're seeing with structured streaming, where we can just append stream to the read. We're going to access the data stream reader. We pass in our schema. And in this case, we're going to specify the amount of files we're going to process at a single trigger. This makes it easier to perform in a demo capacity, but this is probably something that you may want to tune differently if you were running this at scale. And then we're going to access, in this case, we've saved our data as Parquet. So let's go ahead and run this. And I don't think I loaded my model, so we're going to load our model. And while that's loading, now we can see what's going on here. We've loaded our model, and we're going to pass our streaming data frame in as an input parameter to our model. And the result is a scored stream. So once we've defined that scored stream, we can display the predictions and the various features that are going to occur in that data set. Okay, so we can see that our stream is initializing. And so now we can see we have labels, features, and predictions, and this data is continually streaming in. Now, as we mentioned, there are some limitations with scoring models using ML pipelines right now, but that's not the only option you have. So one particular example is using model export, and this is a new feature that we're rolling out in a private preview at Databricks. And the idea is to use Spark, and specifically that batch training, to train that model, build that model. So in this case, you might be using your pipelines. You have any required transformers or estimators that you need to extract the relevant value from your features. And then you can use something called a model exporter and export this model. What this does is it creates a class that you can instantiate inside of something like a JVM. So now once we have our model that we've exported, in 3 you can see we are retrieving that model inside of an external system. So this may be a simple Java application that you have running inside of a JVM anywhere. From there we can import our serialized model, load our JSON data, and transform our JSON data to create our predictions just like we did with pipelines, except in this case, we're totally detached from the Spark context, which is really neat.
Yeah, and that reminds me of what I was going to say earlier, which is that even though we're kind of centering this talk around how we can use structured streaming and machine learning together, essentially, Spark is a lot more heavyweight than what you need to do real-time scoring. Because again, similar to our producer, it's a one record, one operation, and return the result type of thing. So there's not really a need to parallelize that kind of work to start a Spark context, start a Spark cluster. So an ideal solution for this kind of use case would be to go ahead and train on a ton of data using Spark that tends to produce really good results for your models, then export that model out into a lightweight Java or JavaScript type application, which could then be called easily with very minimal overhead to score records as they stream in. In addition to our model export, I know some of our clients have worked on some libraries like MLeap and tested that out. It was a little bit outside the scope of our talk today, but there are certainly, it's an ongoing conversation in the industry, so there are certainly tools out there that you can try as well. And again, shameless plug here. We've been showing you the tools in Databricks. You can see it's really easy to use and run. It presents a very unified analytics platform, both from an end-to-end pipeline capacity, from ingesting your data, connecting your people all the way through your business application, as well as just the collaborative aspect of the platform, allowing you to kind of break down the barriers that traditionally existed between data engineers, data scientists, and data analysts. And we're introducing Databricks Runtime 3.0 with some proprietary components, including optimized for cloud Spark, DBIO, and DBES. And you can try it for free today.
All right, thank you. We wanted to draw your attention to our code that's available on GitHub. You can capture the link up there. Again, we have our Twitter hashtag if you have questions that we're not able to get to today. So at this time, we'll take some questions. Thank you.
Yeah, let's give him a quick round of applause.
Thanks.
And all of these slides will be posted by the summit too, so you'll be able to access the link that way too. But with that, we'll go ahead and kick it off with some questions. Come on up, stand up at the mic, and ask away. Fish on the line.
We can motivate that with some questions that we thought might be common.
I think we have somebody.
Oh, okay.
Do you recommend any specific tools for live logging for streaming applications, in particular in Python?
Python.
I'm not.
Let's say typical debugging use case.
Yeah, so as we said, at Databricks, we would use structured streaming to create those dashboards. That may not be practical based on your application. We have some customers that use Grafana. I'm not quite sure if that is something you could use with Python, though.
Here, come up to the mic if you have a question.
Do you offer any Angular packages or any recommendation to tie together with structured streaming to be able to custom build dashboards?
Sure. So the question is, do you provide any Angular packages? And is that for the scoring piece or just for being able to interact with structured streaming from Angular?
Mainly for structure, but also.
I haven't worked with any packages myself. I'm not sure if you have. But.
So I'm not aware of us offering anything to basically retrieve the structured streaming results and visualize them in your own web page, for example. However, we are working on the ability to score that model in something else. So we mentioned the ability to score in a lightweight Java application, and it's certainly something that we're talking about. Do we want to create some JavaScript libraries where you could then score the model from directly?
My name is Raj. So Michael talked about the continuous version of structured streaming today in the keynote, right? Not the micro-batching version. So this thing is supported in both micro-batching and the continuous version of the structured streaming?
I believe so, but I'm not as familiar with the.
So what we just displayed today is supported with both batch and streaming.
Batch itself is dependent on micro-batching concept, right, internally?
Yes, that's right.
Yeah.
So today, I think Michael talked about 2.2. They have introduced new layer on top of it, which is continuous. It is not a micro-batching anymore, right? That's why he brought up that 100 milliseconds to less than 10 milliseconds.
So we've only tested ours on 2.1 so far. So I'm not 100% sure on.
Yeah, the continuous part of it is going to be sometime in the future. That's sort of where we're actually moving to. And yes, this would support it because basically what happens is rather than setting off Spark jobs incrementally, right, which is the incremental execution, sort of batch style, this would launch one task and then you feed new data into it. And so everything that Spark supports would support that. Does that make sense? Yeah.
Thanks, Bill.
Cool. Let's give him another hand. We'll do one more question.
Yes, sir.
You mentioned the limitations on the algorithms that you can use with structured streaming. Are there plans to make those available, or are they simply impossible with structured streaming? That's part A. Part B, are there workarounds like landing some of this data temporarily in memory or whatever, and then doing queries against that and doing whatever you want, something like that?
Yeah, so that's a good question. In terms of sort of the workarounds, you could kind of build your own vector assemblers, for example. However, it would be a little bit more overhead at the time in terms of, is it on the roadmap, something we're looking at? Yes, it's something that we're definitely talking about, something I think is the community should pay attention to as well. However, as I mentioned, because it is a lot more overhead to score in real time in Spark, it may not be the best solution to invest too heavily in.
And just to add to that, the open source community has already identified that this is a problem. And I think right now we're trying to figure out the right approach based on kind of what Carol has described and some of the practical limitations associated with it. Databricks itself is not prioritizing adding this, but we certainly hope that the open source community does. So right now there are no plans, like we don't have a roadmap or an estimated date where this will be fixed.
There's anything fundamental that sort of prevents it, right? At the end of the day, it's just sort of, executing over time. And so I think that it's something that will eventually come, right? That's part of the vision, effectively the unified engine for all of these different processing techniques. But it's not something that you can just get overnight, right? And so, yeah, I think that certainly move towards there, but not quite there yet. And so with that, let's give them a final round of applause. And yeah, come up if you have any other questions.